Relating slope and y-intercept to linear equations, lesson 7 notes. Point slope form. Right? Point slope form is y minus y1 equals m, which is the slope, times x minus x1. When would we use point slope form? Well, let me go back up to example 4. If you remember, in example 4, I told you that when you're given a chart, you look for the x equals 0. Because if they give you x equals 0, then the corresponding y value is your y-intercept. So over here, they gave us that x is 0, therefore negative 5 is our y-intercept. Well, they're not always going to give you 0. If you look here at example 7, there's no 0 in the x column. Example 8, no 0 in the x column. Example 9, no 0 in the x column, and so forth. So when you're not given a 0 for the x column, in other words, they don't give you the y-intercept because the value of y is when x is 0, or the y-intercept is the value of y when x is 0. If they don't give you that, then you have to use point slope form. All right, so let's start with first the slope. M represents the slope. Go ahead and write that down. Next, they're going to give you a point on the graph or a point in the chart. So you're going to have a point that's x1, y1. Then you're going to take this y1 value here and you're going to put it in right there. And you're going to take the x1 and put it in there. And obviously the slope would go, whatever they tell you the slope is, that goes in for m. Now you need to be careful with this equation because it's y minus y1, x minus x1. And if you remember, we've talked about this before. Those minus means you take the opposite of x1 and the opposite of y1. So try it again. So that means that I'm going to circle it. So that minus sign means I take the opposite of y1, and this minus sign means I take the opposite of x1. I'll explain more what I mean by that when we start to do the examples. All right, so let's look at an example. First of all, pause your video and make sure you have everything written down. All right. So first, this negative 12, we're going to plug that in for y1. This positive 8, we're going to plug that in for x1. And this negative 1/2 would go in for the slope. So again, this is x1, y1. right, so let's plug it in. Y minus, well, y1 is negative 12. So you could write y minus negative 12 like that. You could write y minus negative 12 like that. Or, because we know that's the opposite, you could simply go to y plus 12. Now, be careful with the y plus 12 because sometimes people tend to mess that up. So I'm going to do y minus negative 12 like this. So I've got minus negative 12 equals, well, the slope is negative 1/2. And then x1 is 8. So minus 8. All right. Now, I take and I do, well, first of all, I want you to notice this right here. Doesn't want to draw ovals for me today for some reason. All right, so I want you to take notice to the double negatives we have here. All right, remember when you have a double negative, you want to make it positive. So this would become y plus 12. And at the same time, I want to do the distributive property on this side. So I'm going to take negative 1/2 times x to get negative 1/2 x. And then negative 1/2 times negative 8. Two negatives would become positive, and half of 8 is 4. Once you've done the distributive property, there's only one more step left to solve for y. I want to get y by itself, so I need to get rid of this plus 12. The opposite of positive 12 is negative 12. Now, where would I put negative 12 over here? Well, I wouldn't put it with the x term because they're not like terms. I would put it under the constant term. So then my final answer would be y equals negative 1/2 x, and 4 minus 12 is negative 8. So not knowing the y-intercept, I need to use the point-slope form. I plug in the slope, I plug in the coordinates from a point, and I solve for y. So that is point-slope form. Don't worry, we're going to be doing lots of examples of these so you can get the hang of it. If you have any questions, let me know.